Okay, so here's a look of the new mounting plate. I've only got 2 bolts in the steel plate at the moment, the 2 furthest away. I've got to order some shorter ones. I've only got long ones at the moment. You can see the stainless cap head bolts. They hold the motor down onto the plate, and then obviously the bolts from the plate down to the original mounting bracket. So that's all hooked up now, which means I can use the lathe again manually to make some more of the parts for the conversion. I'll bring you around the other side and we'll look at the VFD control. Okay, so hopefully this will show up a little bit. I've got the VFD, variable frequency drive here. This is the 3rd VFD I've wired up. I've got 2 on my milling machine. They are better quality ones on the milling machine. They're Danfoss, which I found to be really good. This was a cheap unit, but so far it seems to be fine. It's cheap enough that if it does break, it's not really a problem to replace it. It's pretty simple to wire up when you know what you're doing. As I said, this is the 3rd one I've done, so not too bad. At the moment I've hooked it up to just use the buttons and potentiometer on the unit itself, which means I can change the frequency there. Programmed it for 50 Hertz maximum, which is what the motor specifies. And there's forward and reverse, and then obviously your programming buttons as well. So I'll just show you if I hit run and then increase. You can probably see the motor running there, and then obviously if I turn the clutch on. Go. So the reason I bought a new motor for the conversion was so that I could wire up an inverter to the Acorn, Centroid Acorn DIY CNC board, which I've already tested, which works fine. So that means on the computer CNC lathe software, I can control the speed and direction of the lathe motor all in the PC. And once I hook up the encoder, which will be attached to the back through a toothed pulley. So it means I can do rigid tapping, single point threading of any pitch, which will be interesting because I used to have a gearbox on here, a thread cutting gearbox, but it's only for imperial, which meant I was stuck if I needed to do anything metric really. And also constant surface speed will be available, so the software will know and be able to regulate the speed directly. So none of these controls will be used once it's all set up. I've just programmed it at the moment so that I can still use it manually, so I can turn it on, use the lathe once the saddle and apron are on there, and still be able to make parts to be able to complete it. So this is just a close-up of the VFD. As I said, this was an affordable unit. It probably comes under various different names, but it's all the same, import quality, but seems to be very usable. There's no fan on these, so I'll be interested to see how warm they get. It will be under the bench, sealed off from the workshop, and I do have a few USB fans to attach, hopefully controlling the airflow to keep the temperature inside the unit down, because that's where all the CNC electronics are going, all the stepper drivers and so on. If you're not familiar with VFDs, basically standard household power cannot run 3-phase electric straight out of the box. you need one of these VFDs. So basically 3 of the wires down the bottom here are standard, just plugged into the wall and then wired up here, the live, neutral and ground. Then the other 3 are actually going to the 3 poles of the 3-phase motor, and then this black cable is also a grounding cable. So the wiring is pretty simple. There's a whole list of parameters that can be changed using the keys here, and there's a small manual to go with it. So when I rewire this up to the CNC board, I'll program this to ignore the buttons on the front, and it will take the information from the board which is hooked up to the PC. So that will control the speed and direction. Basically these pins down here are the ones used to link up to the Centroid Acorn board, and I'll be making a video a little bit about the wiring for that. There's about 4 or 5 wires that connect up here to make that all work, which I've tested. There's actually another short video of a bench test running a stepper motor, but I haven't got a video of it running the lathe motor at the moment.